Good morning, teacher.
Good morning, amor, ¿cómo vas? ¿Cómo van, chicos guapos? ¿Todo bien? Cruz Herrera.
Sí, teacher.
Good morning, ¿cómo van? Cruz Herrera.
Good morning.
Good morning. ¿Qué bestia con el madrugado, madrugadores?
Good morning, teacher.
Good morning, amor. Jiménez. Voy a ir registrando su asistencia de una vez, ¿ok? Let me see. Okay, I have Ojeda Romero. Hello, Mati. ¿Cómo va tu hermanito? ¿Todo bien? Qué bueno, amor. Vicky Herrera ya está. Good morning, ¿cómo van? Benjamín Cruz, Albán, hello, a ver, Cruz, ya, ok. Francis Flores. Let me see who else, ok, ya. Los otros chicos se han quedado dormidos. Good morning, amor, Fabricio Farinango, he's connecting right now. Ok. ¿Cómo han pasado? ¿Por qué tan callados? ¿Siguen dormidos?
No,
Sí.
tengo frío, eso es lo que me llama. Y lo que me llama la camita.
Y ustedes. Es que en las mañanas a mí me sale un poco como que de alergia, algo así, no sé. Carrera. Doménica Sandra.
Alérgica a madrugar.
La nariz, ¿verdad?
De ley, alérgica a madrugar. Sí, pica la nariz, así como que está a cada rato estornudando, achis. Hinojosa. Ok, let me see. Esperemos hasta que se cumplan los 3 minutos y ahí sí empezamos la clase. A ver, déjenme ver. Good morning, amores. Good morning. ¿Te cortas el cabello, Gabito?
Good morning, teacher.
Good morning, amor. ¿Te cortaste el cabello, Gabo, o te peinaste? ¿Cuál de las dos? Ah. ¿Sigues con sueño? ¿Cuándo anda el Gabito? ¿Cuántas clases tienen hoy?
4.
Ya van y se toman una siestita. Terán y Cobos. Terán y Cobos. El lunes igual no hay clases, así que el lunes pueden dormir un poquito más. Montaña.
A las 12.
¿Por qué mi clase es el lunes, teacher?
Montaña. Fecha cívica. Montaña, ¿dónde está? Fecha cívica, chicos.
Presente, teacher.
Hello, amor. ¿Ya? Ok, ahora sí vamos a empezar, ¿ok? Let me see. Ya, ok, vamos. Ok, así que hoy a echarle un poquito de ganas, que estamos tarde, como usted sabe, chicos. Estamos un poquito atrasados en el contenido. We're going to start, please, with the morning prayer. So please put your hands, close your eyes. 1, 2, 3. Lord, may nothing separate
You today. Teach me how to choose only your way today.
So each step get me closer to you. Show me what
Tell me word
and
by
not
the
by
word
feelings.
and not my feelings. Help me to keep my heart pure and undivided. Protect me from my own careless distracted my wants, my desires, my thoughts, and how things should be. Help me to embrace what comes my way as an opportunity rather than a personal inconvenience. Give me the chance to learn, to my work responsibility, and to be respectful with all the people around me.
Amen.
Okay, very good. Don't forget you have to have your cameras activated. So Catherine, please turn on your camera right now. and we're going to start, okay? Can you remember me in what page do we end the last class? ¿En qué página nos quedamos? 119?
Yes.
119, yeah. We have to work with the consolidation. Okay, let me go to this. Okay, the first question about the consolidation, we were talking about the force, okay? So we are going to go to question number 1 and we have answered the question. What is force? So we are going to make a quick summary about this. Let me go up, up, up. And here we have the definition of force. So we know that it's every agent capable of changes to a state, you can read, sorry, to a state of movement or rest of an object or modify a shape of a body. Okay, so write please that in on question number 1. We're going to go quickly today, okay?
Good morning, teacher. Good morning, teacher.
Good morning. Okay. And we have the next question that we have, what differences can you establish between contact forces and forces that act at a distance? Remember when we have a contact forces are going to touch each other, okay? And with non-contact forces, they are not going to touch. Eso ya creo que escribimos, ¿no es cierto? Sí.
Sí, ya hicimos, teacher, sí.
Okay, number 2. Number 2 is a look at the picture. You have a bike race there. Okay, they are 3 bicycles. They are in a racing. They say, make a list with all the forces that act upon the cyclist as he moves forward. ¿Qué fuerza ejerce cada uno de el ciclista? We have ahí tiene que poner friction force. We have, let me see here. No, this is not. Let's see. Okay, so we have the type of forces. We have the contact force. We have the friction force. Do you think that the cyclists make this kind of force, the contact force, yes or no? Mateo Ojeda. The cyclist has a contact force? Mateo. Mateo Ojeda. Do you think that the cyclists make contact force? Yes or no?
Yes.
Yes, they do make a contact force, okay? Because they have to touch the bicycle, they have to sit on the bicycle, so they make a contact force. Right there, contact force. Do they make a friction force, Vicky Herrera? Do they make a friction force? Remember that the friction force, they are going to apply for stopping or slowing down. Do the cyclists make a friction force, yes or no?
Yes.
Yes, they do make a friction force because in one time or one moment of the race, they are going to stop or they are going to slow down, okay? So right there, please, friction force. Okay, let's go to the next type of forces. Do they act with the force that act of a distance or non-contact force? Let me see. Or non-contact force. We have the gravitational force and we have the magnetic force. The gravitational force, remember, there is it generates attraction between two masses. That is why all objects are susceptible to gravity. Do the cyclists make gravity force, Domenica Santa Fe? The cyclists have a gravitational force, yes or no?
Yes.
Yes, they do have gravitational force, so right there, gravitational force as well. Do they have magnetic force, Carla Cantuña? Do they have magnetic force? Do the cyclists have magnetic force, yes or no?
Yes.
Yes, do you think so? Remember that the magnetic force is a property that some materials have to attract or repel each other, ¿ok? Entonces, ¿hay algún tipo de magnetismo en los ciclistas? I don't think so. I don't think so. I don't know what do you think so, okay? Yo pienso que no. Okay? I think that's not. Let's go to the next one. Let me see. Sus compañeros recién se están levantando. Okay, very good. So we have, we're going to leave it just with 3 types of forces. We have we already write gravitational force, we write the friction force and contact force, okay? We're going to stop there in this consolidation.
Good morning, teacher.
Good morning, Amor. Okay, we're going to stop there in this type of consolidation. We're not going to do the rest of the consolidation, so we're just going to skip to page number 120, okay? Let's go to page 120. And we're going to talk about mass and force, okay? Remember the meaning of mass, massa, and force, o materia, okay? Can you read for me, please? Let me see. Paulita Andrango, can you read? What characteristic is unique in a body?
Cubic.
Okay, no, in your book. Read the information that we have
De más.
on the book. A ver, ya yo leo, que no me está entendiendo. Dice, vamos a la parte de consolidation. You have mass and force, okay? Bueno, voy a leer desde anticipation. Mass and force, anticipation, name. The physical characteristics that you can see in a football ball. You have a football ball and you have, I think it's a kid boy there. So they are made by different materials. One is going to be much heavy and the other is going to be much lighter. One is more bigger and another one is smaller, okay? Look around and you will realize that everything has something that makes it special and unique. However, what surrounds us has characteristics that may not always be perceived at first sight. A primera vista, first sight. Construction. What characteristic is unique in a body? What characteristic that can't be seen do bodies have? Every nature can be differentiated based on different aspects. You have the shape and you have size. Here we have the shape, we have a spherical shape, we have cubic, and no geometric shape. And it could be big, medium, or small, okay? So we have different shapes and we have different size to describe an object, okay? Then we have the thickness, the color, and the texture. The thickness is going to be thick, thin, and slim. ¿ok? Thick, grueso, y va a ir disminuyendo. Thin and slim, ¿ok? Muy delgado. And we have some textures, okay? We have a smooth and we have rough, okay? So we can describe with all these elements or all these characteristics an object, okay? It says, but there are characteristics that can be observed at first sight. The characteristic is not so visible in bodies in the amount of matter each one has. Okay, so you don't know if it's going to be heavy or light, si va a ser pesado o liviano, okay? You are not going to see that in first sight. Usted no va a decir, esa pelota parece que está pesada, okay? No lo va a decir, solo va a ver las características externas, okay? Let's go to page 121. And we have the measurement unit of mass according to the IS is a kilogram. However, one can also use its equivalences. Highlight, the measure units of mass according to the IS is a kilogram. However, one can also use its equivalences. So you have the magnitude and you have the equivalences. You have 1 kilogram, it's going to have 1,000 grams. Metric on T, it's going to have as well 1,000 kilograms. 100 weight is going to weigh 100 kilograms. The pound, la libra, is going to weigh 453.5 grams. Okay, and then you have an ounce that is going to equivalent to 28.3 grams, okay? And we have, can you read the next paragraph, please? Mati Romero, can you read, please? Between a wooden cube.
Between a wooden cube and a metal cube from the same size, we know that the metal one has more mass, thus it has more mass between two living things, such as we know that the bigger one has more mass.
Excellent. So we know we are going to compare, okay? We are comparing two objects here. We are comparing two objects. You know, it is bigger, it's going to have more mass. And if it's smaller, it's going to have less mass, okay? You know it that. Entre más grande, más masa. Entre más pequeño, menos masa. And as well to the weight, it's going to be heavier. The bigger one is going to be heavier. And the smaller one is going to be light, okay? So we have a big dog, more mass, or a small dog, less mass, okay? Can you read the next one? The more mass body, Isaac Chakinga. The more mass a body has. Isaac, en tu libro, abajo de los perritos, the more mass a body has.
The more mass a body has, the more difficult it is to stop or move it. But if it has less mass, the application of force requires to change it is less too.
Okay, very good. So we have the more mass a body has, they are more difficult to stop or move it. For example, a truck, that big truck, los camiones grandes or los trailers, okay? That's why they have a lot of accidents, okay? Because they are going through the road or the highway, but they don't stop easily. Por el peso que ellos cargan, es difícil parar, okay? They're going to, them to stop is going to be very, very difficult. That's why occur a lot of accidents, okay? So because of the weight, okay? And let's go, I'm going to read the rectangle the pink rectangle, it has the mass of a body is amount of matter that this one has. In physics, the mass quantifies an inert in the universe. Let's go to the next PowerPoint presentation. Well, I have here the equivalences, the measured unit of mass, and we have the mass of a body is the amount of matter that these ones have. In physics, the mass quantifies the inertia in the universe. Can you read the next paragraph, please, for me? Let me see who. Vicky Herrera, can you read, please? The mass quantifies inertia.
What? I don't listen.
The next paragraph of page 121, the last paragraph.
The mass quantifies the inertia means that the more mass a body has, the more difficult it is to stop it if it is in movement or to change its state if it is at rest. On the contrary, the less mass, the easier it is to change its state of rest to movement and vice versa.
Okay, very good. So we know if it has more mass, it's going to be difficult to move or to stop. If it has less mass, it's more easier to move or to stop or to change its state, okay? Let's go to page 122. We're going to talk now about weight, okay? Can you read for me, please, Genesis Perez? Weight, el peso, weight. It is very common to confuse.
It is very common to confuse mass with weight, but in physics we make a big distinction between these two concepts.
Okay. Can you continue reading, please, Vicky Elban?
Weight. It is the common to confuse mass with weight.
Okay, the next paragraph. Eso ya leyó Genesis.
All bodies are made by matter, mass, which is attracted by the gravity exerted by Earth. These direct relationships between mass and gravity makes all bodies have a weight.
Okay, very good. Highlight all this paragraph, please. All bodies are made by matter, which is attracted by a gravity exerted by Earth. This direct relationship between mass and gravity makes all bodies have a weight. So because of gravity, we have a weight, okay? Highlight, please, all this paragraph. Gabo, can you read the next line, please? Weight is the product. Yeah, read, please. Weight is a product. Lea.
Is a product of the mass by the gravity that affects it.
Okay, very good. So we know that the weight is a product of the mass by the gravity that affects it. So highlight that part, please. And we know that the unit of measure of the weight is the Newton, okay? That's the unit of measurement, okay? So we're going to highlight that as well. And then we have, in order to know the weight of a body, the following formula is used. To know your weight, it's going to be applied this formula. M is going to be for mass, and it's going to be multiplying by gravity, okay? So P refers to weight, M for mass, and G for gravity. The gravity in all the bodies that we have on Earth is 9.8 meters per second square, okay? That's the gravity, okay? That's the unit of the gravity, okay? For example, if you have 10, I don't know, 45 kilograms, you're going to replace weight is equal to mass. You're going to have 45 kilograms and you're going to multiply for 9.8 meters per second square, okay? Then we have summarizing the weight of a body depends on its mass amount of matter, and both are proportional to each other, but they are not the same. Using the formula, if we say that a person has a mass of 80 kilograms, his weight will be of 784 newtons, okay? So you have to replace, replace the formula. P is equal to 80 kilograms. You're going to multiply for the gravity, that is 9.8 meters per second square, and it's equal to 784 newtons. Now you're going to do it by yourself. Usted debe saber cuánto pesa más o menos, ¿no es cierto? I don't know, maybe 40, 45 kilograms, okay? So do it, can you take your weight, please? Va en la partecita de abajo, tiene suficiente espacio. You're going to multiply there, okay? For example, let me see. Okay, for example, you're going to place here. First, you're going to copy the formula and multiply it for G, and then you're going to replace. Can you tell me, let me see who can tell me. Francis, do you know your weight? ¿Cuánto pesas? No. Who knows the weight? ¿Quién sabe su peso? Más o menos, no quiero exacto.
No sé que peso poco.
Ay, chistoso. ¿Quién?
Yo también.
¿Qué?
Teacher, yo ya me voy a pesar ahorita.
A ver, pésese rapidísimo.
Teacher, yo creo que 42 kilos.
Okay, 42 kilograms. Okay, so we have 42 kilograms. We're going to multiply. The unit of gravity is 9.8 meters per second square. Okay? So you have to multiply. Can you multiply this, please? ¿Quién me multiplica esto?
44.
42 y le va a multiplicar por 9.8. Do you have it?
411.6.
Okay, 411.6 newtons. Remember that the unit of the weight is the newton. So this will be the weight of your body on Earth, okay? Y así es como tiene que hacer con su peso, chicos. Ready? Pero como veo que no saben su peso, invéntese más o menos cuánto pesa. No haga con 42, haga con 45, con 48, con 40.
Teacher, yo tengo 44.6.
Ok.
Yo-
Very good.
Entonces yo le pesar 20. creo.
Okay, very good. Let's go to the next page, 123. We have consolidation. Question number 1, answer T if it's true or if it's false. Weight is a property of matter, true or false? Can you tell me, sorry?
False, teacher, false.
False, yes, very good, false. Next one. ¿Ya ves que estás enojado, Fabricio?
No, teacher, estoy mal con
ya. Tráeme bonito.
Estoy mal con
Okay, the next question is going to be for, let me see. I'm going to ask Jamilet. Mass is an example of the value of weight, yes or no? True or false?
Yo, teacher, yo.
A ver, Fabricio.
False.
False, okay. Okay, very good. The next one. Mass is a property that all bodies have. True or false?
True.
True, excellent. A scale measures the weight of a body.
False.
A scale, una escala, measures.
True. True.
Es true.
Okay, true, excellent.
Ya ven que me estoy... True.
Number 2, underline the correct answer. Okay, you're going to, no creo que pueda, bueno, ahí véale cómo se le marca una X o como sea, okay? The force exerted by Earth on all bodies is related to, ¿verdad qué dice? The force exerted by Earth on all bodies is related to mass, weight, pressure, force, or acceleration.
Mass. Pressure.
Mass.
Mass, I think that is mass. Yeah, mass or weight. Okay, because if you have mass, you're going to have weight. Okay. The next one. The unit of weight is gram, Kelvin, kilograms, Newton, or Celsius?
Newton.
Newton, excellent.
Oh.
Okay, number 3. Answer. According to the scale, how much do you weigh? Ahí va a poner lo que usted calculó su peso, okay? So right there, your weight. If you have 411.6 newtons, 150 newtons, lo que usted haya calculado. Okay? And number 4, it says calculate the weight on Earth of the objects mentioned below with their corresponding masses. You're going to have the ball, 90 kilograms, bat, 1 kilogram, bottle, 3 kilograms, and a child, 50 kilograms. You're going to use the formula to calculate the weight, okay? Do it now. You have 5 minutes to do this. You have 5 minutes. What you have to do, multiply 90 kilograms, multiply into 9.8 meters per second square, and you're going to have the results, okay?
Dicha la primera de 882.
Ok, cuando yo le pregunte y me dice en inglés, ok? Thank you, amor bello. Okay. El único que está despierto.
Un kilogramo.
Finish?
No.
You have 1 minute left.
I finished, teacher.
Okay.
Sí. I finished, teacher.
Okay. Very good. Okay, let's see. I'm going to... Christian Terán. The ball, you have 90 kilograms. The weight will be... ¿Cuánto te salió ahí? ¿Cómo? 800?
Sí. 800.
882 newtons, ¿no es cierto? Ok.
Sí.
Right there, please, 882 newtons. No se olvide de poner la unidad, ¿ok? The bat, Melanie Cobos. Bat.
The bat is 98 newtons.
9.8 newtons. Okay, you're missing the comma there. 9.8 newtons. Elizabeth Cisneros, the bottle. Elizabeth.
Yo, teacher, yo.
The bottle.
29.4 Newton.
29.4 newtons, okay. And the last one, the child, Catherine Jimenez. Kathy. The last one, the child.
Yo, teacher. Yo.
No, teacher. No, please.
Yo, teacher. Yo.
Yo, teacher.
A ver,
Sí, pero el
Fabricio.
Emilio y la Vicky están diciendo.
490.
490, the unit?
Newton.
Newtons, excellent. Very good. Okay, very good. Let's go to the next page. I'm going to read this quickly. We just have 3 minutes. So I want to end this unit because we have to start the next unit now. We have magnitudes and direction of force. You have anticipation. In the following image, you can see a book on a table. Read the statement and discuss. You have, there is no force acting upon the book. Is no force. Everything is going to exert a force, okay? Everything that is on the world is going to exert the force of gravity. So all the elements are exerting a force, okay? The book exerts a force on the table, yes, because it's laying on the table. So yes, it's going to exert a force on the table, okay? We have construction, the magnitude. A magnitude is a characteristic of an object that can be measured length, mass, surface, volume, and temperature. Remember that the meaning of length is longitude, okay? So it's going to measure length, mass, surface, volume, and temperature are all magnitudes. You have the balance, you have the deformation, and the change of movement. The balance, we're going to highlight all this information, okay? Is the sum of forces. The net force that act upon a body is equal to 0. This body is in a balanced equilibrium. So highlight, please. Is the sum of forces, net force that act upon a body is equal to 0. So the net force is going to be equal to 0 if it's a balanced force, okay? Then we have the deformation. If we apply a force on a body, this will change its form. Highlight. If we applied a force on a body, this will change its form. Then we have the change of movements. We have, if a body is at rest, it will start to move, okay, or it starts moving. This is where VI is initial velocity and VF is the final velocity. Then we have, if the body's movement, it changes velocity in magnitude, direction, or sense, okay? We have, there is a woman that is riding a bike. you have V1 and it's continued there, it doesn't stop, okay? If the force is applied in the same direction and the sense of movement, the speed in the mobile increases, okay? So it's going to be an acceleration there, okay? And the last one, force, V1 and VF. You have a traffic light there that is on, I think it's on red light. If the force is applied in the same direction and in the opposite direction to that movement, the speed decreases. So it's going to slow down or it's going to stop, okay? Okay, let's go to 125. Page 125. I'm going to take 2 minutes from your time, okay? Number one, we're not going to do it because we have to explore around our homes. So we are not going to do that. We're going to go directly to number 2. It says, answer the questions. This question will be to Abigail. This said, does every time you exert a force on an object at rest, it starts to move?
Yes, because a force move and the object. There are the necessary force to move a book to the bed, or to the table, or to the table from another thing. If you're using your hand and your hand have the force necessary to move that object.
Okay, so right there, yes. Yes, because it's going to apply a force. Okay, very good. The next one is going to be to Domenica Santa Fe. What do we mean when we say that a force changes the state of movement that a body is at? What do we mean when we say that a force changes the state? Okay, va a cambiar el estado. It's going to change an state of movement that a body is at. ¿Qué significa?
Que está cambiando de lugar para caminar.
Okay, it's going to change. It could happen a deformation or a change of movement. Okay, ahí póngale. It's going to have a deformation or a change of movement. Ok. Y hasta ahí nos vamos a quedar. La siguiente clase, chicos, la 126, 127, 128 y 129 no lo vamos a hacer. Nos vamos directo a la unidad 6, ¿ok?
¿Por qué?
Eso, mis amores, porque las evaluaciones sumativas no estamos trabajando, ¿ok?
Ah, ok.
Eso, mis amores bellos. Un gusto haberles visto. Ahorita ya nos igualamos, ya podemos trabajar tranquilos, ¿ok? Eso, mis amores bellos, les quiero mucho. Cuídese, por favor.
Ya igual, teachercita, la queremos demasiado.
Bye, bye.
Chao. Se cuida.
Ustedes también, amores.